Penjara Pudu, once a crime landmark in central Kuala Lumpur, was built by the British between 1891 and 1995. Located along what is now Jalan Hang Tuah, is known for its small size and its massive mural painted on inmates in the 1980s. Once considered the longest in the world, over a long history, it houses many residents, including the famous gangster Botak who was executed in 1981. The prison closed in 1996 and briefly became a bar in 2010. Demolition began to make way for urban development. By 2012, most of the place was gone except for the main gate and a section of the wall which was preserved for the historical gain. In its place today stand the Bukit Bintang City Centre, a sleek modern hub which offers both residences and entertainment. This transformation sparked public debate was necessary progress for the loss of cultural heritage. Penjara Pudu was more than a prison, it was a symbol of colonial history, social memory. Its experience highlight a deeper question: how do we balance modernization with preserving the past? We will briefly highlight the demolition of Penjara Pudu, a well-known heritage site in Kuala Lumpur, and the major issues revolved around demolition case. First, space volume and segregation. The demolition produced massive amount of materials, concrete, steel, bricks, and a portion very little of it was sorted at source. This means recyclables were mixed and mostly landfill, which is a huge missed opportunity. Environmental concern. That poor handling also led to environmental issues, dust, air pollution, natural soil contamination, and added stress on already full landfill sites. Lost usable and heritage materials. Much of the building was made from quality wood materials, bricks, and timber which could have been reduced use or preserved, but they were discarded along with the chance to retain cultural value. Third, weak regulation. Thus, all of this was made worse by Malaysia's weak enforcement of demolition risk guidelines, especially when it comes to historically significant sites. In conclusion, this case clearly shows why we need better planning, stronger policy, and more sustainable practices in handling demolition waste, especially for heritage-rich projects.
Hey everyone, let's talk about innovation development. We are diving into a concept of recycling and reusing construction demolition material. Yeah, that part of brick and concrete can actually be part of the future. So here the innovation that our group would like to give for the case study of Pudu jail. When we recycle or reuse material from demolition site, we are basically showing off what the circular economy looks like in action. Instead of tossing all the waste into a landfill, we give it a second life. That means less stress, less pollution, and way less need to dig up fresh material from the ground. But wait, it gets better. This approach can actually save a ton of money, less from raw material extraction and processing, all the way to shipping and even buying new stuff. So business get to cut costs while also being eco-friendly. Plus community benefit too. C&D, that's construction and demolition. Reuse can create local jobs and even help keep the architectural vibe of an area alive. Imagine modern building that still keep a piece of history in them. So yeah, innovation in construction isn't just about tech and big machine. Sometimes it's about being smart with what.
Next, I will present our comprehensive strategy on manage, mitigate, and sustainable in handling the construction and demolition of the Penjara Pudu, known as a C&D material. C&D waste is actually the material that produced during the construction, demolition, renovation of the buildings, bridge, and the roads. These include the wide arrays of the materials such as the metal, glass, wood, salvage building components, and other debris. Based on our case study at the Penjara Pudu, our strategy is structured into several core pillars. So first one is actually the pre-demolition planning. This phase, we emphasize the importance of conducting the environmental audit, the material inventories, and also the feasibility study using the BIM design tool. Next is the demolition of the C&D material in a certain area of the Penjara Pudu that will not disrupt the structure of the building of the Penjara, and the material itself can be reused and recycled back by the 3R system. Then we take a second approach by proposed 3R system using deconstruction. We carefully deconstruction rather than demolish a valuable area as approach to preserve the usable material and heritage value. Then we reduce the C and D material by performing controlled deconstruction of structural element. We step in selective soft stripping that carefully remove non-structural elements like door, window, wood panels, sanitary fixtures to store, reuse or reseal. We avoid the mechanical of demolition to prevent the breakage. Next approach is reuse by sorting on-site reusable material. Reuse the preserve and reintegrate the heritage material to maintain the cultural value and reduce the needs of the newest resource. For example, historic brickwork and stone, carefully dismantle and clean the material for use in pavement, pedestrian walk, public space, and facade treatment. For the timber beams and the doors, refurbish and reuse in interior fitting for local museum and cafe that inspired by the present architectural style. For example, like this, the gravy that located in the Subang Jaya. Next is recycle by convert the waste into the new construction input. Process and recycle remain the C and D material by divert the rest of the material from the landfill to transform them into a usable resource. Last approach is adoption of technological integration. This mobile recycling actually portable that can recycle and process the concrete, asphalt, brick directly at site. Last but not least, we want to adopt the dry processing recyclers that has zero water use.
Okay, now for the cost-benefit analysis, which we must compare the traditional method versus the circular economy that our team proposed. Okay, there are two things that I got for this slide. First is the cost, or in other words, the weaknesses. First, the increasing labor cost by deconstructing rather than conventional demolition. Secondly is the deconstruction takes longer time, thus increasing or delay the project schedule of the construction project. Third is sometimes we use more specialized equipment, also the custom one, rather than conventional. Next is the increased sorting in the storage cost by sorting the material and storing the item from the deconstruction process. Finally, it will affect the processing cost for recycled material such as crushing concrete. Okay, second is the benefit. Firstly, it will lower the disposal fee due to low waste on conventional landfill. Second, it will create a new revenue from selling recycled material. Next, it will reduce material purchasing costs by reducing from recycled material. After that, we will reduce long-term costs and taxes related to landfill conventional uses. At last, it will preserve historical items such as main gate at Penjara Pudu, which by the way is our case study for the project. Now for the sustainability impact or innovation impact, where we must evaluate the long-term sustainability benefits of our innovation. Okay, there are two types of benefit, which first the environmental benefits. For the beginning, it will reduce landfill waste and storage. Next, it will decrease air pollution from natural resource material extraction from construction, like timber, manufacturing from factories, and also transportation from diesel lorries. Lastly, it will reduce greenhouse gas emission like methane in the long term run. Now, second is the social benefit. First, it will create new opportunity for job creation for recycle industry. Second, it will give positive image for communities, especially residents that are near the disposal or construction factory area. Third, new market will emerge and more demand and supply from recycling construction material and technology will created. Okay, at last, property value increase around disposal and landfill area because of the reduces pollution and also high green environmental awareness. In conclusion, by transforming construction and demolition waste from a burden into a valuable resource, we can unlock substantial economic benefits through material reuse and energy efficiency while drastically reducing our environmental footprint and paving the way for a truly circular economy in construction. Okay, that's all from our group for the presentation and goodbye.